Alright, this is Devon Pruitt from Challenge 2016, and for week 2's problems, we're doing two problems from Chapter 5. The first one is from Lesson 4, number 32. And we're going to find the definite integral from 0 to 1 over pi over 3 of 1 over 1 plus 4x, 1 over 1 plus 4x squared with respect to x. Alright, just looking at this function, we can go by the trend that, and the pattern, that the derivative of arctangent of u with respect to x equals 1 over 1 plus u squared times the derivative of u. Alright, so if we look for u, we'll see this in this conglomerate x, or just 2x squared. Alright, so if u equals 2x, then du equals 2. Alright? So normally the derivative of this arctangent, the derivative of arctangent of 2x is 2 over 1 plus u squared, or excuse me, 4x squared. But we don't have that here, as you can see, and we only have a 1. So in order to compensate for this at the top, we need to have 1/2 in our equation from 1 over 0 to 1 pi, 1 over the square root of 3. 1 over 1 plus x du. Okay? Alright, so we end up getting the antiderivative to be 1/2 arctangent of 2x evaluated from 0 to 1 over square root of 3. Alright, and you note that this arctangent at 0 will be 0. So that's the lower limit. The upper limit is 1 over square root of 3. So final answer will be 1/2 arctangent of 2 over root 3. Alright, for chapter 5, section 6, excuse me, we have question 101, which we're trying to find the area under the curve of y equals 2x over 1 plus x squared, and the x-axis, or y equals 0. Alright, and we're going to find the definite area under the curve between -1 and 1. Okay? Alright, so there's two ways to find, well, I guess what I should say, the top function minus the bottom function will equal the area between the two curves. But you have to find at which intervals, which one of these two is the top function, which is the bottom. Because a lot of the time they do change the shift. So we can do this one of two ways. The first way is that we can say that when the points meet, then most of the time they'll either do this, or they will change. One will be under, and which one will change to be over. So what we can do is to find that direct point. We can set the two equations equal to each other and get 0 equals 2x over 1 plus x squared, which if you multiply 1 plus x squared on both sides, you get 0 still equals 2x, and the only way for 2x to equal 0 is to be multiplied by 0, so it's at 0.0. Second thing you could do is to graph the puppy, which comes out to be something like that for the graph of y, and this is obviously the x-axis, -1 to 1. So we're finding essentially two integrals, because we can't go in the one integral from top to bottom. So we're going to separate it up, and first of all it's going to be the integral from -1 to 0 of the top function, which is graph of 0, the x-axis minus 2x over 1 plus x squared with respect to x, plus the second area between two curves, which is the integral of 0 to 1 of the top function, the graph of y, 2x over 1 plus x squared minus 0 dx. Okay? Alright, now that we have that down, we can say that let's try and find a way to integrate this. What comes to mind when I see these two? Is that we could use natural log. And the reason I say natural log is because the derivative of natural log of u with respect to x equals 1 over u times derivative of u. And I guess you're wondering why we can't use arctangent, because when you say derivative of arctangent of u equals 1 over 1 plus u squared du, and our du, which would be x squared, or u, which would be x squared, du would be 2x. And since we don't see an x on top, we can't necessarily take the integral with an x just coming out of nowhere. There has to be a reason why that x is there, so we have to use natural log here. So for the first one, you have the integral (-1 to 0) of (-2x) over 1 plus x squared dx. U equals x squared plus 1. Du equals 2x, which makes sense. Alright, because, okay. So really, it's also important to note that we can kick this negative sign out, so it would just be negative, the negative of this integral. Alright, so we can say that ln of u, we can take the antiderivative and be it that ln of u of x squared plus 1 evaluated, sorry, that's a negative, from (-1 to 0. We can take that. Then for the second one, which was just adding from 0 to 1, the same integral, but positive, to be plus ln of x squared plus 1 evaluated from 0 to 1. And evaluating these two functions here, the first negative natural log, excuse me, with upper bound, which would be negative ln of x squared plus 1 of (-1), which is just be the natural log, negative natural log of 2. Excuse me, that was the lower bound. I'm going to start that over, excuse me. Alright, so the upper bound would be negative natural log of 0 minus negative natural log of (-1). (-1 plus 1, which would be 2. So for the upper, for the negative part as a whole, the first integral would be negative ln of 0 plus ln of 2. Alright, plus the integral, ln of x squared plus 1 evaluated from 0 to 1, which would just be upper bound the ln of 2 minus ln of 1, which would just be 0. Eat dog. Ooh. Alright, sorry, I messed up in this upper bound here. This is actually x squared plus 1 of 0. So that becomes 0 plus 1. That becomes square root plus 1. Should be 0, which would become ln of 1, which approaches 0, and 0. And this one's also 0. So what we have left is ln of 2 plus ln of 2. So we get 2 ln of 2. And that's your answer. Sorry, young ass, for the messiness. Yes. This is all for now. Thank you so much for watching.